Okay, so this is the last video for this chapter, so yay, almost there. So in this chapter we're going to look at all the different types of synovial joints, and there are 6 of them. Synovial joints are classified, when we start trying to describe them, we classify them by the shape of the bone surfaces that articulate, and so there are 6 types of synovial joints: ball and socket joints, condylar joints, plane joints, hinge joints, pivot joints, and saddle joints. And so we're going to look at all 6 of these over the course of this video. So we'll start with a ball and socket joint, also known as a spheroidal joint, because it is built with a spherical head on one bone that fits into a cup-like cavity, also known as a fossa. Hopefully you remember that from chapter 7. So that spherical round head fits into this fossa, and that allows great freedom of movement. The spherical head can move in many directions, and these ball and socket joints are the most freely movable of all the types of joints in the body. They allow flexion, extension, abduction, adduction, rotation, and circumduction. So we can do lots and lots with our ball and socket joints. And we have 2 primary ball and socket joints. The shoulder joint is one, hip joints are the other. And so here is a schematic of what that ball and socket looks like. So here's the ball fitting into its cup, and so we can pull it upward, pull it downward, we can move it in rotational movements, we can go side to side, so on. Here is the hip joint. Here you can see the head of the femur, how it fits into the acetabulum, the fossa of the hip, and again, lots of movement allowed there. The next kind of joint that we're going to discuss is the condylar joints. Condyles, if you remember, they're sort of an oval surface that has an oval convex surface, so kind of this shape, and they are similar to ball and socket joints, so the condyle is kind of a dragged out ellipsoidal type of surface, and it fits into a similar shaped depression in the second bone. And with condylar joints we can do flexion and extension, abduction, adduction, and circumduction. So if you want to demonstrate a condylar joint, lay your hand down on your desk in front of you and have the palm facing up, and if you raise your index finger, then when you raise the entire finger, you're moving a condylar joint there. So you can get that come here movement, and then you can move it side to side, sort of the teacher pointing and wagging her finger at a bad student. That's what a condylar joint can do. And so the places that we see condylar joints is with the distal metacarpal making a joint with the proximal phalanx, so numbers 2 through 5, so the index finger, middle finger, ring finger, and the pinky. And also we see condylar joints at the distal radius, where it makes a joint with the proximal carpals. So here are the proximal carpals. We have the scaphoid, the lunate, and they create a condylar joint there with the distal radius. Alright, so 2 down, 4 to go. The third joint that we're going to look at is the plane joint, also called gliding joints, because they are built of 2 relatively flat surfaces that glide over each other. So they allow these very short sliding back and forth and even some twisting motions. They're the least movable of the synovial joints, because mostly because they're such short little movements that they can do, and because the flat surface doesn't allow any kind of kind of, I don't know, what's the word I'm looking for? You can't get flexion or extension from a plane joint. They can only slide back and forth. So where we see them include the carpals, the joints among the carpals and the tarsals, and they're at the intervertebral joints where the transverse processes of the vertebra have little synovial joints with each other. So you might say, well, Chuck, what are you talking about? I'm sitting here moving my wrist, and wow, I can do all sorts of motions with the wrist. And I say, that's not because it's a single plane joint. It's because we have so many different plane joints in so many, that are moving in so many different directions, that we actually have lots of flexibility in the ankles and in the wrists. But it's not a single joint. It's many joints all working together that allow that great flexibility. Okay, so those are the plane joints. Now let's talk about hinge joints. Hinge joints allow only flexion and extension because they're prevented from the shape of the joint prevents them from making other motions. So with a hinge joint, just like hinges on a door, you have a convex surface fitting into a concave surface that creates this hinging motion. And so, if you, let's say you're flexing your elbow joint here, you can't get side-to-side movement in a healthy elbow because of the way that the joint is built. And so hinge joints are seen in the elbow, the knee, between the proximal and middle phalanx and the middle and the distal phalanx. So the joints amongst the phalanges, those are all hinge joints. All right. Number 5 is the pivot joint, also known as a trochoid joint. And with a pivot joint, you have a cylindrical surface. So you have a cylinder, and it fits into a ring that's composed of parts of a second bone, and usually there are ligaments involved as well. And so this allows that cylindrical axis to rotate within the ring. It allows this cylindrical axis to rotate within the ring of the second bone and the ligament. So the ligament is holding that axis against the surface in which the bone surface, and so and where we see these, one place is at the atlantoaxial joint. That's there between C1 and C2 in the neck. So the dens of the axis is the cylindrical piece, and it rotates against or within the foramen of the axis. The dens of the axis rotates against within the foramen of the atlas. There we are. That's what I wanted to say. So and then it's held against that bearing surface of the two bones by the ligament of the axis. We also see a pivot joint at the radio-ulnar joint, where the head of the radius rotates against that radial notch that's right near the trochlear notch. So that radial notch right here. And so the head of the axis can rotate around or against that radial notch, and it's held in place and rotates also against the annular ligament that holds the radius up tight to the ulna. So pivot joints, they allow that rotational movement that we associate with the head shaking no, or if you hold your elbow and then rotate your wrist around, then you're going to be using that rotational movement of the radio-ulnar joint. Okay, so the last of the joints are the saddle joints, also known as a sellar joint. And it's hard to describe them, but if you imagine a rider sitting in a saddle on a horse, so the rider's legs kind of hang down, and the rider can go side to side in the saddle. And in fact, you can imagine, sort of a cheesy comedy western where the rider slips right off the horse, almost, as it rotates around the horse toward the horse's belly. So you get that motion, and then the rider can also hinge front to back, because there are these reciprocal concave and convex surfaces that fit together that allow both this motion, this side to side as the rider is like slipping around the saddle, and then this front to back rocking motion. So this can be pulled forward or it can be pushed back. So that is the saddle joint, and it allows great flexibility at the thumb. And so it allows motions, and this is a motion that I forgot to show you in the video that I made of all the joint movements and the names of the joint movements. So let me just give it to you right here. There is opposition and reposition. Those are the opposite movements here. So opposition and reposition, those are the two primary joint movements that this saddle joint that we find at the base of the metacarpal in the thumb. So where the metacarpal, the first metacarpal, and at the proximal end of the first metacarpal makes a joint with the distal surface of the trapezium. So here we have the base of the thumb, that metacarpal, and here's the trapezium. And so this joint here is one of these saddle joints. And so if you want to see what opposition looks like, bring your thumb and pinky together. That's opposition. And then if you put them back so that your hand is flat once more, that's reposition. So opposition brings your pinky and thumb together. Reposition brings your pinky and thumb apart from each other. And you can do opposition with the ring finger, the middle finger, and the first finger as well. So when we make the OK signal, where you make the round circle with, between your thumb and index finger, that OK signal is also opposition. And then returning your hand to flat would be reposition. So be sure that you know that movement as well. So there you are. So the last piece, the last videos that I've made are a video of me, the one that I told you that I would make, showing the different movements of the joints. And so you can follow along in your notes package with that video. And then I also included an additional video where you can test yourself. So sort of in random order, I gave you a bunch of different movements in the same way that I will on the test. So you can try quizzing yourself that way. So there you are. Happy studying, and we'll see you on Wednesday for class.